Um, uh, I'm gonna say yes.
And why is that?
Is if you sub in any value for x, you'll get an answer.
I'm gonna say no. Why is that? Yes, because 2 or more y values are the same. So, it's because for it to be a function, it has to have an inverse function. This thing has a repeating y coordinate. It's going to repeat many, many times, in fact. What domain would make y equal sine x a function? So if you were to...
Is that where it's like sine minus 1 of y or something like that?
That would be inverse, yeah. Where could you start and stop so that the sine graph doesn't repeat, doesn't have the same y coordinate twice?
So the two y coordinates here are 1 and minus 1, aren't they?
Yeah.
And so could I just keep on stopping at 0 or something? And that'll give me the y coordinates again.
Yeah, so where could you start, where could you stop?
I'm not entirely sure what I need to do.
I'm not entirely sure either. Let's see. So we start from 0. We go right. So far it's okay. Then we hit the maximum. If we go any further, then it's going to repeat the y coordinate.
Yeah.
And so that's kind of where we stop. So we could go from, we could have the domain from 0 to 90. Can we extend it? So it also goes to down to minus 1. At the moment, the range is like 0 to 1.
Could we times the x coordinates? Or
we could go the other way. So there's a lot of ways we could do this. We could go this way as well. So we haven't actually repeated the y coordinate. The y coordinate doesn't repeat. If we go any further, it's going to start repeating. If we were to have, let's say, sine graph like this, in fact, anywhere, so long as it doesn't repeat, will work. So let's say we went from here. What is that? So from 90 to 270 would work as well. Because it never has the same y coordinate twice. But if we go before 90, then it will. If we go after 270, then it will again. And so it doesn't matter where you restrict, as long as it doesn't have the same y coordinate twice. Because that would be like, whatever, many to 1 or something. The convention is that we do it between minus 90 and plus 90, or between minus pi over 2 and pi over 2. What range would that give?
180? Or just pi? Yeah.
In terms of y coordinate. So what would the y coordinates be?
They would be... Would I have to do minus pi over 2 to see what the y coordinates would be?
Yep.
So minus 1 and 1?
Yeah, that's it. And let's say minus 1 and 1. So that would give the full range. Sometimes it'll be written as like y equals the f of x. And so instead of saying y, they'll say f of x, or we'll say f of x. Because sometimes you'll have like 3 different graphs, like f of x, g of x, h of x, something like that. And so it helps to distinguish them. Let's see. Yeah, so sine x, it's not a function because it will repeat the same y coordinate forever, many times. So we have to restrict it. So let's say between minus 90 to 90, so that it doesn't have the same y coordinate twice. So then it becomes a function, and that's so it can have an inverse function. The inverse function of sine x is called arc sine x. So you've seen that on your calculator, like that.
Yeah.
What do you know about inverse functions? Do you know anything about them?
You can only put sub in values which are in between minus 1 and 1.
Yep, that's true for sine x. For in general, inverse functions in general, you may not already know anything about them.
Oh, is it the small value approximations or something like that?
Nope. You may not know anything about them. It is essentially, they are a reflection in the line y equals x.
Okay.
Is this what I've said here? And a simpler way is with the function, the x coordinate in the inverse function is the y coordinate. Y coordinate in the function is the x coordinate in the inverse function. So it's a reflection in the line y equals x. You're literally swapping x with y. And so y equals sine x contains a sixth pi and a half. What is the corresponding point on y equals arc sine x?
A half a sixth pi.
Correct. I made this back in 2015. One night. Still going well. Okay, y equals sine x. This is the domain and range. Domain is possible x values, range possible y values. What is the domain and range for arc sine x?
Is the domain minus 1 is smaller or equals to y is smaller or equals to 1?
Very close. Domain is for the x.
All right, sorry. Oh, and then the range will be like minus pi over 2 is smaller or equals to y is smaller or equals to pi over 2.
Yeah. You literally swap the x with the y.
Yeah.
That's it. Okay. Y equals cos x. It's same idea, and y equals tan x. For them to be a function, the convention is you restrict their x between 0 and pi for cos, and then the same for tan x as sin x. What is the range for cos?
The range for cos, would that be minus 1 is smaller or equals to y is smaller than equals to 1?
Yeah. And so arc cos x.
So will the domain be minus 1 is smaller or equals to x is smaller or equals to 1? And then so 0 is smaller or equals to y is smaller or equals to pi.
Yep. Tan. Very tricky.
So
the tan graph is that one. Going from positive infinity to negative infinity. Any idea how you would express that?
So would I? Oh, sorry.
That's y is an element of the real numbers. So it's basically it's like y is between negative infinity and positive infinity.
Okay.
And they write as y as an element of real numbers. Okay, arctan x.
I'm guessing x is an element of real numbers.
Yep.
And the range will be minus pi over 2 smaller or equals to y smaller or equals to pi over 2.
Yeah. Pi over 2. And actually, while I'm here, that's a pretty good thing. Here we have y equals cos x. Here we have y equals tan x. And earlier we had sine x. And so we have this y. For the previous one we had y. And so what you might say is this one is the f of x. This one is the g of x. And instead of saying y is between those things, you would say the f of x is between them. And instead of y for this one, you say the g of x. Because y equals the f of x for this, y equals the g of x. So it's just a name to give to it, so it gets less confusing. That's all it is. Okay, there we go. Any questions so far?
No.
Okay, so we want inverse functions of sine, cos, and tan. We can't inverse function because they're not functions, and so we restrict their domain so that they don't have repeating y coordinates, so that they are functions. Okay, how do we do this?
I'll just put this into my calculator.
Yeah, let's just do A.
Okay. 26.6.
Yep, and they changed it into degrees. Is probably something in degrees. It's 30 degrees. Yep, fine. Okay, how about this one?
So do I just do cos minus 1 of 0.5 and see if that'll give me another answer?
You could do that.
I got 60 again.
And so that's first answer. How do you get second answer with
Oh,
cos?
because it's cos, do I need to do... was it 360 minus 60?
Yes.
And so will it be cos at... Oh no, x is 300.
Yeah, so x can also be 300. Great. Cos 60 is 0.5. Cos 300 is also 0.5. Infinite number of solutions, but 60 is called the principal value because it's closest to 0. Okay. Any idea about this?
So put this into my calculator.
Sure.
I got 30.
Yep. What do you know about arc sine and sine?
I'm not sure.
Or why did you get 30?
So does arc sine and sine just give you what x is?
Yeah, it's like they cancel each other out. They're inverse.
Oh, right. It's like times and divide. Yeah, okay.
Yeah, it's like that. I don't even know root and power. And so I'm just showing it works both ways. So you can do sine arc sine. You can also do arc sine sine. So that's grand. What do you think answer is here?
100.
Put it in a calculator.
100.
Calculator.
Okay. 80.
What? How do you get second answer for sine?
Oh, right. So you do 180 minus 80.
Yeah.
Oh, no, 180 minus 100, sorry, all the way around. Yeah.
Yeah. No, 180 minus first answer. Yeah, is 100. And so, yes. So this one is the principal value. And then this one is like second answer, let me call it. And just watch out for that. Sometimes you get an answer and you think where that come from. It's because calculator is automatically giving you the principal value, not necessarily the one you're expecting. Is that right here? 80 is the principal value because it's closer to 0. Okay, how about this?
So, okay, so it'll be x is arc sine 2, and then it won't give me an answer. Do I then need to say it's because the range for arc sine needs to be minus 1 and 1?
Yeah, that's it. Because y is between 1 and minus 1. Yeah, no solution, it's outside the range. Look at this graph. Okay, how about this solve?
Is that just sine pi over 3?
Yes, well done.
And so I got 0.018.
And that's in radians, is it?
That's in degrees.
Go for it. Radians.
I'll give it in radians. Root 3 over 2.
Root 3 over 2. Okay. And how about this one?
That'll be root 3 over 2.
You'd think so, wouldn't you? However, it's also outside the range, and that is because the range of arcsine x is between pi over 2 and minus pi over 2, because the domain of sine x is pi over 2 and minus pi over 2 to make it a function. Another thing we need to be aware of, that the domain and range, so this one, sine x is equal to 2, you just kind of intuitively remember sine is, its range is 1 to minus 1. But the range for arcsine x, because you're swapping the x and the y, will be minus pi over 2 to pi over 2. You'd flip it the other way, something like that. And so, yep, something to watch out for. So this is what the graph looks like when you get,
Yep.
yeah, it goes down to that, up to that, okay. There we go, okay. Now to the bad questions. Okay, this is what we saw just a second ago. Y equals arcsine x. Sure. Sketch the graph of y equals arcsine x. Okay. Weird that they ask you to do it right after showing it to you. Any idea how you do that?
So just through minus pi over 2 and pi over 2.
Yep. Ouch. Hang on. You're good at remembering stuff. I'm not. Sine. You have to restrict it. We swap x with y. And so, what is this one? That's pi over 2, 1. And so it becomes 1 pi over 2. The other one must become minus 1 minus pi over 2. So instead of going up and down to 1 and minus 1, it goes left and right.
Yep.
Yeah. That's pi.
Would it also be the same for cos as well? Like if it was arc cos, would it just be pi over 2 and minus pi over 2?
No, because the cos graph is symmetrical. So
Alright.
cos graph symmetrical about the thing. So that would repeat the y coordinate. So with
Yep.
cos, you do it from here to here.
Alright, okay.
If you did it from like here to here, you get the same y coordinate. Hang on. So we have to go from pi over to 1. So it goes through 0, 0 and there. So it's kind of like that. Is that how it works? I think that was it.
Yeah.
Let me see. So hopefully it looks something like that. And of course, Andrey, you know me. Graphical calculator. How could you do the graph?
So, well, I literally just put in arc sine minus 1 of x.
Let's try it.
I think I need to adjust mine. Can you tell me how to adjust mine, please? Because it just gave me a straight, like an almost straight line.
Ah, yes. We could do zoom. Is it zoom? So 5. So arcsine x. So mine looks all right. Shift zoom auto.
Yeah. Yeah.
That's a bit better. Now, it doesn't show it going to a shift view window. So it's kind of handy that I know that it goes from y minimum. Let's change that to minus 100. And dot, I don't know, 100, scale of 10? I don't know. That's alright.
Yeah.
Yeah, it's alright. Okay, that's if you're still, you can always do it that way. They did it first way as well. Okay, so that's what arc cos looks like. It's a rotation of cos, or a reflection in the line of y equals x. Same with arctan, and it's been restricted. That's what they look like. You can graph them, you can do them manually. Okay, how would you do these?
So I'm guessing just put it into my calculator.
Yeah, I think that's fine. We did one already. They did a bunch of malarkey. Okay, now stuff gets weird. Very weird. Let me now, hold on. Go to the Buki. This is 6.5. Yep. So I have the exam questions, just because it's quite a jump. Yeah, we could, without using a calculator, Okay, how would you do question 2?
Put it into my calculator.
Yep.
So would that also be in degrees?
I think these are all in radians, it says.
Okay.
So I don't think there's any to that. Okay, I think we're fine. Let's just go straight for this exam question then. I think I might need extra questions from the book for something else. Any idea how we would do this?
Put it into my calculator.
So let's try it. It's also, you could do it as a series of transformations. So I'm just wondering about zoom and all that. Don't know how to do this.
Yeah, mine looks pretty good.
Yeah. Okay, great. If you're happy, I'm happy. Find the exact coordinates of the point where the curve crosses the x-axis.
Minus 9.550253 E minus 3 and then 0.
What was that last part? Oh, E.
E.
Yeah.
Is that a logarithm or something? Or
No, I'll go on. What was it? Minus
9.550253
E.
Yeah.
And is there anything after the E?
Minus 3.
I believe that means times 10 to the minus 3. Like exponential minus 3 means like times 10 to the minus 3, so it's like a small number, like 0, 0, 0, because it's 10 to the minus 3.
Yeah.
955. However, they thwarted us. Exact coordinates. And so how can we get exact coordinates?
Would I need to do y equals to 0.
Yep.
And so do I just do 0 equals to pi over 3 plus arc sine x minus a half?
Yep.
Well, I got like a long decimal number. It doesn't have an e in it this time.
Step 1.
Should I press stats and equals or?
Give it a go.
What? No, it didn't work.
So then step 1.
It didn't work.
Okay.
How do I go back? Sorry.
Do it manually. How can you get x equals? Or what are you putting into your calculator, like solve equation type thing? Is it?
Yeah.
Yeah, that's gonna be the same problem, I think. Okay, how do we do it manually?
So, minus pi over 3 equals to arc sine x minus a half, or even sine. Or could I do sine pi minus pi over 3 equals to x minus a half?
Yeah.
And plus a half. Yeah.
Here we go. X equals a half plus sine minus pi over 3. And if you put that in your calculator, you should get a similar decimal to what we got.
Yeah, I got 1 plus root 3 over 2. Well, they got 1 minus root 3 over 2. I got 1 plus root 3 over 2. Oh, it's because I put pi over 3. If I put it in minus pi. Yeah, I got 1 minus root 3 over 2.
Root 3 over 2. So that's simplified. And so then as a coordinate, it is that, and y is 0. Great. Yes. Okay. So calculator, yeah, gives approximate answer. If they said 3 sig fig, great. If they want exact, have to do it exact. Any questions there?
No.
That's a shame calculator didn't get that one. That's fine. Graphical never works. It's an exam question. We'll do this.
I think just put this into my calculator.
Yeah.
Five over 6 pi.
I'm sure it's correct. There we go. Okay, they're giving away these marks. Okay, weird time. Let's think about this before we start doing wacky stuff. No, let's go in. Let's do it. Okay, let's try this. Any ideas here?
So, possible values of x. Am I just shoving in 0 is smaller than x, smaller than pi over 2?
Yeah.
Oh, sorry, I missed the arc sign. So, it'll just be, so x is equals to sine k essentially.
Yep.
So does that mean I have to do the range will be sine 0 is smaller than sine x, smaller than sine pi over 2? Oh, sine k, sorry, sine k, yeah.
Yeah.
And then express in terms of k.
Hold on. You have to actually simplify these
Yeah,
terms.
so that will be 0
Mm-hmm.
and 1.
There we go. Yeah. B.
So I know that x is sine k.
Mm-hmm.
So do I need to now find out how many cos k's are in sine k or something? Or
You would use an identity that allows you to swap between sine and cos.
is it tan?
Nope. It has to. You would have to have some kind of equal sign. Tan would just introduce tan. It is our old favorite. Squared.
Sine squared plus cos squared equals.
Yeah. Maybe I'll just use theta actually. They're already using x. Okay. Actually, maybe I'll use k.
So 1. So would it be like the square root of 1 minus sine squared k is equals to cos k?
Yep. And they want it in terms of x.
Okay, so this will get a bit confusing. Would it be like 1 minus, so the square root of 1 minus x, xk?
Oh, it's only confusing because you're doing the entire question in one step. Sine k is x. What is sine squared k?
X squared.
Yes. Now you can make cos the subject.
So will it be square root of x of 1 minus x, x squared?
Yes. There we go. I compromised and let you do it in 2 steps. Part 2 is tan k.
So would I do something like tan k is equals to sine k over cos k?
Yes. And so in terms of x.
Should I sub in from before? Should I do like sine squared k
No,
plus? I don't know.
in terms of x.
Oh, so sine k is x squared. Oh,
Sine.
x. Sorry.
Yep.
So will it be x over 1 minus x squared?
That's it. I believe. Okay. I'm in part C.
Would it be that I won't be able that it won't the answer won't work because the answer needs to be put. Oh, it's because the answer from x square root 1 minus x squared will be positive, and so it will affect the answer because this next new range only gives me negative numbers.
Mm-hmm. So, can't square root a negative. So no solutions, or the way you said it is much better. Let's say k is now in the fourth quadrant where cos k is positive. So cos k is the same, but there's no change, and they're what? So this is the second misprint that I saw in this exact part of the book. Different authors write different parts of maths books. And whoever wrote this, I'm not happy with them. The value of k remains the same, and there is no change to tan k. You mean there is a change? Maybe we're wrong. Let's see. So, okay, hold on. Cast diagram. So before, our angle k was in between 0 and 90. So that's here. Everything's positive. My favorite quadrant. Now it's between this thing. So cos is positive. So this one's going to be the same.
Yeah.
But sine is definitely going to be negative. So sine k is x, that'll become minus x. Yeah. So tan will become negative. But cos stays positive. Surely. They even worded that answer weird, didn't they?
Yeah. Yeah.
Okay. All the other stuff, they're surprisingly good at. I don't know why I'm still surprised by that. Any questions there?
No.
Okay. Yes, this is the one. This is the one that I want to build up to. Let's see. Let's see. Let's start in reverse. This one, 6.5. Is there nothing, Bucky? Is there nothing? Must I do everything? Okay, they make this man do everything. Alright. Any idea about this one?
Okay, so. So y is equals to a times tan minus 1 of x plus b. Do I need to solve to get a and b on one side or something? Oh no, would I need to sub in minus 3 and 0?
So that was my thinking. Okay. Y equals a arctan minus 3 plus b. Okay, what next?
So.
Is right. Let's see. It's a transformation. Y equals arctan x. Y equals arctan x. What is its y-intercept?
Would that be arctan is 0?
Yep.
And so would that just be 0?
So arctan x goes through 0, 0. This goes through minus 3, 0. Does that tell you anything about A or B?
So that tells you probably what b is.
What is B?
Would be minus 3.
I believe B would be plus 3 because it works in reverse with like plus 3 means it goes 3 to the left.
Oh, yeah.
Counterintuitively. Okay, how about A?
Do I just need to solve for A by subbing in all the values?
Go for it. Will that work though? Maybe it won't.
So for A, I got, if this is correct, minus 0.36603.
0.3663.
Minus 0.3663.
Who knows? Y equals arc tan x. What is its range?
Would that be like minus pi over 2 is smaller or equals to y is smaller or equals to pi over 2?
What is the range for this one?
For which one, sorry?
This graph? Arctan?
Yeah.
Range for this one.
But it's minus pi and pi.
And so, what does that tell us?
Oh, it's been doubled.
Yep.
So does that mean that A is equals to 2?
So I believe that means A is 2, and we said B is positive 3. So 3 to the left. A is 2, B is positive 3. That's it. Sorry, there was a part B. They want y-intercept to three decimal places.
So just sub everything in and put 0 instead of x.
Yeah.
And then I got 2.498.
8. 2.498. That's it. Great. It's a transformation in reverse. So they performed the transformation. You have to say what the transformation was. It moved 3 to the left. So it's plus 3 in the next bracket. And it was a stretch scale factor 2 y direction. And so A is 2. Any questions about that?
No.
So I don't have more questions for that. Really feels like it needs extra practice to just throw in one, but we shall see. Okay, how about this?
So would that be cos minus pi over 4 plus 3?
Yep.
And I got 6 plus the root 2 over 2.
Great. Okay. We're getting real. Have you seen this notation before?
Does that just mean function?
It just means function. So it means f such that x maps onto, if memory serves. Okay, A.
Sketch the graph of. So is that just what? Is that just y equals to g of x? Oh no, that'll be y equals to f of 2x divided by 2. And so is that just going to be, that'd be a half times arc sine x.
I think you're getting ahead of yourself. Let me see. Am I crazy or is it not just arc sine x?
F of x is arc sine. Oh yeah.
I'm crossing my fingers on that one. So you would just sketch arc sine x, I think. And what is the range of arc sine x?
Would it be minus pi over 2 and pi over 2?
Yeah. And I'll put the f of x in the middle instead of y. Because maybe I'll need f of 2x or g of x or something with the other stuff. So I know lots of y's everywhere. Okay.
I think would it just be double that? Would that be 2 arc sine x?
It would be f of 2x, which is not the same
So
as 2 arc sine x.
that means it's in the bracket. So isn't it that anything that's inside of the bracket you actually double?
No. So what type of transformation is it?
Oh no, it'll be shift sine 2x.
Yes. Sine 2x. Is it? Yes. It is. And how would you sketch that?
Put it into my calculator.
I'm fine with that, and I believe it would be stretch x direction scale factor a half, and so the x stuff would be halved.
So would it be minus a half? Yeah, it's a half.
Yeah, they didn't ask for that, but yeah. And I think that, yeah, it's squashed in by half. Okay, question C.
So is g of x just going to be arc equals to arc sine 2x?
G of x equals arc sine 2x. Okay. So g such that x maps onto just arc sine 2x, I think, is it?
Yeah, yeah.
And they said give the domain of g.
What does domain mean again? Sorry.
X's, possible x values. The x equivalent of range.
So would that just be like minus a half to a half?
Yep, so we unnecessarily did it earlier, but yeah. And D.
So that's the inverse. So do I need to write the inverse of g of x?
Yeah.
So is that when I do where I do like y is equals to arc sine 2x, and then I swap the x's and the y's, and then I solve for y.
Yeah.
And so that would be equals to sine x over 2.
Yeah, and I'll just write it as a half sine x.
And so the inverse of g of x is a half sine x.
Yeah, so I'll write it their way. G inverse such that x maps onto a half sine x. Yeah, because if you put like sine x over 2, you might think it's in the bracket next to it, so I just put it outside. Which is why, hold on, which is why you said cos minus pi over 4 plus 3. I put the plus 3 first, so it's definitely not next to it. Okay, let's see. So let's get to the graph of arcsine x. We know what that looks like. These are the x's, these are the y's. What else? Y equals arcsine 2x. X is between a half minus a half. So you just, same as arcsine x, except these were squashed. Scale factor a half. So 1 and minus 1 became a half and minus a half. And this one inverse, a half sine x. Okay, 1 minus 1, pi over 2. So they used f of x, I used f of x. Both are acceptable. F of 2x is squashed, a half and minus a half. Arcsine 2x, a half minus a half. Arcsine 2x, that became a half sine y, and then they swapped that half sine x. Yes. And, hang on, did we read the whole question? Yeah, we did. Great. Any questions there?
No.
I'm taking credit for this. I taught you GCSE. This question D. Nobody gets that. Okay. This is real difficult. Let's try this. Hang on. Have I nothing that could possibly... Alright, let's try it.
Okay. So am I just solving for x here?
How would you go about this one?
I feel like I have to solve for x, I think. And then solve it into the 0 is smaller or equals to is x is smaller or equals to 1.
So what's step 1 here?
To square arc cos x.
That's what I thought. A much more elegant way. Let y be equal to arc cos x. And so instead of arc cos x equals, it's y equals arc sine 1 minus x squared. Okay. Solve from there.
So would that be y squared? Oh no, or even sine of y squared equals to 1 minus x squared. And then what if I do like x squared, or even x is equals to square root of 1 minus sine squared y?
Square root of sine squared y. We're aiming towards getting arc cos.
So would I do that by subbing in 1 minus cos squared y?
Very good.
And so I'm going to have to start squaring back, don't I?
You could expand that bracket with a -1, same as
So
subtracting.
would that be 1 minus 1 plus cos squared y?
Yeah. And so you're left with just cos squared y. 1 minus 1 is 0, plus cos squared y.
Yeah. And that'll be, so x squared is equals to cos squared y.
Hold on. The square root of cos squared?
The square root of cos, just cos y equals to x.
Cos y equals x. What's y equal to?
Arc cos x.
And so I believe that's it. That's what we let at the beginning. Let y be equal to arc cos x.
Yeah.
So we had something that was just arc sine. We did lots of stuff to it, and we ended up with what we had to do. And then b.
Do I need to say, because it's arc cos and arc cos ranges up to 1 rather than 0?
Maybe. Is it this thing? X is an angle. What is the thing for arc cos? Arc cos goes to 1 and -1. Hang on. It's outside the range, basically.
Yeah.
Yeah, outside the range, you're right. Let's say, yay, got it all. That's chapter 6 done. So what do you give yourself there?
I think I'll probably give it a tick.
Coolios. And so now we're on to chapter 7. How was that for you, Andrey?
Yeah, that was good, thank you.
Any questions from you in general?
I don't think so.
Alright, well done, Andrey, you did great. I look forward to chatting again next week, and have a nice weekend.
Yep, cheers, thank you, bye.
Goodbye.